So I'll start by thanking Peter and Kenneth, who are the ones who actually implemented all the backend for this work. What I did, and I'm presenting here, is just the deployment of this and the testing of the framework. So big thanks to Kenneth and Peter, and also all the team at CSCS who work on this project. So we do claim we have reproducible HPC software installations, though geeks are saying that we are not giving that. We do think that we can achieve reproducibility. So just one more, that I think we do have problems with bootstrapping sometimes when we move from one operational system to the other, but then that's where the Dockers and containers, they can hook in. But after that, I can assure you that we can have reproducibility with EasyBuild, and that's why we chose EasyBuild and we are going to present. So this is the outline of the talk. I will first start with a background. I think if you're here, you already know how hard it is installing software on HPC, so I won't spend much time explaining all the troubles that we ran into. Then I will talk about the EasyBuild framework implementation on Cray. So this is the work from Kenneth and Peter. And the last part, I will present two use cases. So all the two deployments on our main systems at CSCS with EasyBuild. We have many other systems. We don't have time to talk about them here. So I will focus on two systems that are Cray-based and how we managed to solve the installation problem with EasyBuild. So in the end, I will also show some integration we have now with GitHub for doing continuous integration, for testing the build software, and also for archiving the recipes. So the problem of building HPC software in HPC, as I already mentioned, it's I think it's known from you. So we had the same problem on Cray systems because we have many requests from users, and they have requirements of software that depend on specific versions. So you cannot just do apt-get install on the software that they need. They depend really on specific versions, and these versions need to coexist. So this is a huge problem for the teams maintaining the software, and not always these people using the HPC systems, they are scientists. So they are not developers or sysadmins. They don't have all the background for installing software. So they need help from people with this background and with experience in installing system. Also, the people developing this scientific software, they are not formed on computer sciences or development. So when they produce new packages, often they don't use correctly the build tools. Just to name a few of the problems we see when using scientific software that we don't see in soft common, let's say software outside the scientific world. So we have incomplete build procedure that you don't have configured or installed, and you have to tweak the files manually. Then this is my favorite, interactive installation scripts. This is really the thing that you shouldn't do when you're packaging a software. You should really provide a way where people can install it automatically and not answering questions. Which is your favorite color? Please install it here or not. So please don't do that. Automation is not a new thing. So we should think that there are people working on installing this software at full time. So then the other things are missing documentation, and also the dependency hell. These are slides from Kenneth that I'm just quoting here. So the dependency hell, we can see many software packages that you can have up to 40 or 50 dependencies in only one software, and then if you need to upgrade, then good luck. So this is the big picture. So we have a problem. So the request for HPC user is always growing, and unfortunately the quality of software of packaging this software is not improving. So we have solutions out there for installing regular software, but not specific for HPC. So we have the speaker before just mentioned about spec. So and we have also EasyBuild, but the other tools, they don't really focus on HPC. So the impact of the lack of these tools is that when they have the request for new software, the researchers they spend a lot of time, they lose a lot of time waiting, and then we also spend a lot of time as HPC staff trying to fix that. The other main problem is that it has been already mentioned here, is the very little collaboration among HPC sites. So everyone is doing their own builds on their own sites, and then people are solving the same problem everywhere. And this is not good in the sense that we don't have a common tool or a forum for sharing. So some sites they do work together, but there is no common ground for describing a build. So people are basically redoing the same stuff on all sites, and there's very little collaboration. So this is also true on Cray systems. So that's why we are just moving it's just a use case, the Cray system for the EasyBuild and the HPC build software problem. So we have the same problem on Cray. So just one slide on EasyBuild for those who do not know yet is the framework for installing a specifically scientific software. So it's not for every kind of software, so it's focused. And then the idea is to group all those people who have this experience in HPC, and the know-how of these people, they should be in a single place so people can reuse. That's the advantage. When someone spends hours and hours preparing a build recipe, then someone else can just take this recipe and reuse all this time that someone who's an expert worked, and then you can just reuse this to your local case. So it's based in Python. It started at Ghent University in 2009, and it is open since it's open source since 2012. Now we have community. We have a stable version that is released every 2 weeks. So from my experience, we can always use the new version, and I don't say we had zero regression so far, but every time we had, it was very small and fixed very quickly. So it is something that you can really use on production, even for large scale systems. So this is my word as a group lead of scientific computing support at CSCS. We have more than 500 users, and we have EasyBuild in production since more than 1 year. So there are many well-known scientific software that are already included. You might not find everything, but every package manager is giving the figures with how many software you have. But the thing that you need to do is go there and see how many of your software you can find it. So I encourage you to go there to the website and check if you find your software there, and then you can have an idea if it's useful for your use case or not. So the main features of EasyBuild, you have autonomous building and installing of the software. You also have the logging, so you don't need to care about saving the output. You're going to find the logs of the installation somewhere, and you don't need to worry about that. You have archiving of the build specification, so every time you build a recipe, you have a copy of this recipe somewhere so that you know that you can redo it. So this is one step for achieving reproducibility. Yeah, it's highly configurable on command lines or files. It's up to you, or site-wide configurations. It is dynamically extendable, so you have the recipes, but you can write your own. So you can just extend existing classes and then write the things that are specific to your software. So it is tested and it is actively developed. So you can just go to GitHub to see that. This is just a graphic to show the community that is sane. So it is growing. So for the moment it's growing. I think by the moment when stops growing, you're going just to show the numbers and not the graphs. So for the moment you can show the graphs. It is growing, and You can just look at the mailing list and you can see that it's very reactive, and also on GitHub. So usually there aren't people who have problems that will remain open. Typically people find a solution when they need to contact the community. So just one slide. I will try to avoid getting too technical here, because I think it's better to discuss the ideas here. So I will present quickly the terminology of EasyBuild. So the EasyBuild framework is the part that takes care of writing, installing, downloading the packages, creating the module files, and provides all the functionalities that are common, let's say, for all the builds, for all the software. Then we have easy blocks that are specifics for they can be specific for a software, or mostly they are generic. So you have an easy block for applications that use configure make, for example. You have one easy block for that, and then depending on the application, you might need one as well. But mostly you use only the easy config file, which is a recipe that is, let's say, not generic. You have the version, and that's one of the key ideas of EasyBuild, that you have the versions of the software everywhere in a recipe, so that if someone else takes this recipe and tries to rebuild, it's going to use exactly the same versions. And while other software in packages like EasyBuild, they are more open, more flexible, but then there's no guarantee that you're going to use the same versions and that you're going to achieve reproducibility. Last concept is the toolchain, which is very important. Is the base for any easy config file. It's actually the compiler and also the basic libraries that are used. So typically it's MPI, BLAS, LAPACK, ScalaPack. This is the basic things that we see that is used on HPC. So it's called the toolchain, and it's grouped together. So it's done in a way that it is a base toolchain for building the software. So I move to the next part now, which is the implementation for Cray. So what was missing to use on the Cray system and why? So this is a typical example of an easy config file. What do we have inside for a build, for example? This is one software called GMP. It relies on this toolchain. This is a toolchain which has GCC, OpenMPI, OpenBLAS, so on, and it uses the configure make easy block. And then typically with EasyBuild, you are going to rebuild everything from scratch. You are going to rebuild all the toolchain that you need, because we don't want to use the things that you have already available on the system, because we might not achieve reproducibility. And then the difference on Cray is that the programming environment, it's already there. So since it's provided by Cray, in this case, we do want to reuse the existing software, because they have the optimized version of scientific libraries and also MPI that is optimized for the interconnect. So in the case of Cray, we do want to reuse these libraries, these compilers and so on. So we just created actually Peter and Kenneth created the easy block and the toolchain for GNU, for Cray, for GNU compilers, Intel and the others, mapping the programming environment available on Cray to EasyBuild, so that we can use the Cray toolchain as any other toolchain that it was already existing on EasyBuild. So the three main features that had to be implemented are the support for external module files, then the definition of the toolchains, and the custom easy block. I want to thank again Peter and Kenneth, but I won't go into details to this implementation because we don't have time here. So this is a key feature for the Cray support. So the support for external module files. So before, EasyBuild was creating and building everything from scratch and creating the module files. Here on Cray, we need to reuse these module files. So So there's the support for a file where you map the existing modules to a way that EasyBuild can read. So this is useful it's needed for Cray, but it can also be used elsewhere if you have already modules that you want to reuse. So also the EasyBlock, I will speed up a little bit here because of the time. So the EasyBlock are specific for the Cray toolchains. You can go on GitHub if you want to see the details. Then here is just to mention that we have one toolchain for each programming environment available on Cray, that we automatically map the variables that you need for building software on the Cray, because we have our wrappers on Cray. We don't use GCC or the compilers directly, so we use the Cray compilers. I'll move now for the last part, which is, I would say, it's more interesting from my side, because it's where we managed to use all this infrastructure to deploy software on production. So the two use cases that I'm going to present here, it's first the machine from Meteor Swiss, which is the weather forecast service of Switzerland. They have production systems. It's two cabinets with a production and failover, with a very GPU-dense system, with 8 Tesla K80s per node, so 16 GPUs per node. And this is a CS Storm series. So just I explained what we had in the Cray programming environment. Typically, this machine is already different from the rest. This is a new series that they provide only partial support for the programming environment. So they provide only programming environment Cray and not GNU and Intel. So we had to rebuild our software from scratch. And in this case, even the GCC that they provided, it was not able to compile AVX instructions. So they give you the hardware and they don't provide you a working compiler. So we opened a bug, and meanwhile they took a long time to give an answer, and then meanwhile we rebuilt everything with EasyBuild. It took us a couple of weeks, and now this software stack is in production since more than 1 year. So our main use case, I move on to PitsDyn, which is our main flagship system. So it's a GPU-based system. It has two partitions. So here it's our largest partition with the Tesla Pascal P100 GPUs, and then we have the Broadwell partition. So it's according to top 500 is number 8 fastest supercomputing in the world, and according to the Green 500, it's the second most efficient supercomputing with respect to energy consumption. So this is the list of software that you can find for Cray on the stock EasyBuild repository, meaning that we have already contributed back. And we also have our GitHub repository where we have our recipes, and then here is just the list if you want to find, look for your software. So here is just to mention that we have this GitHub repository where people can also open pull requests and contribute back. It's for PitsDyn specifically. We have also automatic checking of the recipes using the GitHub pull requests builder plugin. So we check everything before merging to the master. We check everything, and then the last thing is that we have the autonomous deployment of the software on the system. So the final comments here is that proprietary and open source software can coexist. So we had the case where we use open source in order to better exploit our system and what we had available. And in this case, we had the best of two worlds, because we have an optimized software stack, and we also had support from community, both community and from the vendor, and also minimizes the risks of vendor lock-in, meaning that we have an alternative. It was the case when we had a problem with the software shipped by the vendor, we managed just to rebuild everything with open source, and then actually don't need the software, their software stack anymore in that case. So it's the best of two worlds, as I said. Okay, slides with links that will be available on the web, and then we have time for questions. Thank you very much.
Thank you, Guilherme. Questions? Time for a couple of questions. Yeah. And the back.
Regarding the vendor lock-in, how many Cray provided applications did you replace?
So regarding vendor lock-in, how many Cray provided applications we replaced? So for the CS Storm series, we replaced all the software stack. So meaning that we don't count on we count on them only for the operational system, and then we replaced from MPI, GCC up to all the things that MeteoSwiss needed for post-processing all the data. So I would say here at least 20 software for all the NetCDF, HDF5, all of this came from EasyBuild, and we didn't have to change much. All the defaults work for them. So I would say 20 software on this case. And then in the future, maybe for the XC series, where we might start looking in also using the open source only, and then we know that other places like Tech, they just dropped all the software stack from Cray, so they use Intel compilers and MPI, and then with EasyBuild we could think about doing the same in the future. So now we have the possibility. So okay.
More questions? I have a question. How is this being received by Cray itself? Because it seems like we are giving the signal to Cray that they're not doing a good enough job in terms of software stack, and you have to put something on top to actually make it feasible.
So for the CS Storm series, the feeling that I have is that they don't really care. It's not important for them. It's the series that they are focusing on it's the low end, not hardware, but the version that for the support they don't really care. That's my feeling. As for XC, they not only because of the efforts on EasyBuild, but from the complaints that we have open tickets that took so much time to resolve, then I think they realize they are not doing a good job, but they don't give any feedback to us. So, but they know, because we have people inside from Cray, they know that we are using less and less their software. Every time we have an error, before or at the same time we open a ticket, we build the software with EasyBuild. So if they don't realize that if we continue like this, we might not needing their software anymore. It's bad for them, but then it's the free market. So that's so.
Okay. Yeah, that's it. Thank you very much, Guilherme.
Thank you.